Okay, good morning students. So now we'll continue the mutual information, which is a topic of information theory. Now in information theory we see the basic portion and we'll see the conditional joint probabilities and conditional and joint entropies. Okay, so now mutual information. What is mutual information? Mutual information is nothing but the number of bits transmitted through the channel per symbol. Okay, so number of bits transmitted through the channel per symbol is called as mutual information, represented by I of x comma y. The number of bits transmitted through the channel per symbol is called as mutual information. So this is the mutual information I of x comma y, which is nothing but h of x minus h of x by y, or h of y minus h of y by x, a mutual information. Okay, so now my question is the maximum mutual information. What is the maximum mutual information? Means, what is the meaning of that? Maximum mutual information means the maximum number of bits transmitted through the channel per symbol is called as maximum mutual information. The maximum mutual information is called as channel capacity. Is called as channel capacity. The maximum number of bits transmitted through the channel per symbol is called as maximum mutual information, or it is called as channel capacity. Now this is the channel capacity. Now, what is efficiency? Efficiency is nothing but a mutual information by channel capacity. Am I right or not? Now, redundancy is nothing but 1 minus channel efficiency, or this is called as utilization factor. You know that this is a utilization factor, or also called as channel efficiency. Utilization factor or channel efficiency. Utilization factor or channel efficiency. Now see here, now we'll see how to find the mutual information. Okay, now here is the question. Consider a two discrete source x and y with conditional probabilities as shown in the figure below. Consider two discrete sources x and y with conditional probabilities as shown in the figure below. Now this is the P of y by x conditional probability as given to you. Now the first point is you have to be identify what is given. He is given condition or joint is the important parameter. Now he is giving conditional probability. Conditional probability as shown in the figure below. Now consider a source x and y, now whose conditional probability is as shown in the figure below. P of x1, which is given as P of x1, which is 0.4, P of x2, which is given as 0.4, 0.6, 0.4. Okay. Now what he is asking is find mutual information. Now you see here first, now this is a conditional entropy. Whenever the conditional entropy is given, we have to identify the channel diagram. See how the channel diagram we can able to write. Now there are two sources, discrete sources, x and y. So x is nothing but here x1, x2, right? Now I am already saying that when our sources x is said to be transmitter and y is said to be receiver. So therefore this x is a transmitter, When x1 is transmitted, y1 is received. When x2 is transmitted, y2 is received. When x1 is transmitted, y1 is received. See here, when x1 is transmitted, y1 is received with a probability of 0.8. When x2 is transmitted, y2 is received. x2 is transmitted, y2 is received with a probability of 0.7. Now see here, when x1 is transmitted, y2 is received. When x1 is transmitted, y2 is received with a probability of 0.2. When x2 is transmitted, y1 is received. x2 is transmitted, y1 is received with a probability of 0.3. When x2 is transmitted, y1 is received with a probability of 0.3. Now this is the channel diagram with the two discrete sources x and y. Okay. Now because why I am writing, sometimes he is giving the channel diagram and you have to identify the conditional probability. Okay. And remember one shortcut method, row addition. Now what is the row addition? 0.8, 0.2, 1. This row addition is 0.3, 0.7, 1. If row addition is equal to 1, this is P of y by x, remember. If column addition is 1, 0.3, 0.2 here, 0.7, 0.3. If column addition is equal to 1, this is P of x by y. Okay, that is the only shortcut. Okay. Now this is the channel diagram. What he is asking? He is asking a mutual information. Now we have a formula for mutual information. What is the mutual information? I of x comma y, I of x comma y. There are two formulas. Now you tell me which formula you have to be used. Okay. So h of x by y is there, h of y by x is there. So which you have to be used? So if I use h of x by y, we required, what is h of x by y? See here, h of x by y, conditional entropy, which is nothing but joint probability into the conditional probability xi by y. Now see here, if you want a conditional entropy, then we required conditional probability of x by y. But in the question, x by y is given? No. So if I want a h of y by x, conditional entropy of y by x, then we require a conditional probability of y by x. But P of y by x is available. So P of y by x is available, then it is very easy. To find joint probability, right? Now this is the joint probability P of x comma y, which is equal to P of x into P of y by x. P of x is available and P of y by x is available. So it is better to go for this formula instead of this, right? So if you want to find this one, first you want to find the joint probability. Now what is the joint probability? The joint probability P of x comma y, which is equal to P of x into P of y by x. Okay. So why you are finding this? Because P of y by x is available. Now I want a joint probability for calculation of conditional entropy. I want a joint probability for calculation of conditional entropy. Conditional entropy is required to find the mutual information h of x by y. Okay. So now P of x by x joint probability, which is nothing but, now I should write like this. This is x1, x2. Now P of x1, what is P of x1? See here, P of x1 is 0.6. Now very simple technique. P of x1 multiplied with this particular row, P of x2 multiplied with the second row, because this is x1 and this is x2. Okay. So because the formula is P of x1 into P of y1 by x1. P of x1 is 0.6, P of y1 by x1 is 0.8. So you can write directly 0.6 into 0.8. 0.6 into 0.2. Now P of x2, 0.4 into 0.3, 0.4 into 0.7. Now which is nothing but 0.48, 0.12, 0.28, 0.1. Okay. Now this is the joint probability. Now this is the joint probability is completed. Then what we require? Once the joint probability is completed, now this is the joint probability is available. So can I find the conditional entropy? Now we require a conditional entropy for finding the mutual information of this. So what is h of y by x? So we required both h of y by x as well as h of y. Okay. This is y1, this is y2. Now first I want to find this is h of y. Now what is h of y here? See, the column addition, remember one shortcut method I am already saying, column wise addition, row wise addition, you should not do in all the cases. Columns are added, rows are added, and that addition is possible only in the joint probability. So if I want a P of y1, some of you are saying 0.8 plus 0.3 is wrong. The column addition, row addition is not possible in conditional entropy. The column addition, row addition is possible only in a joint entropy, joint probability. Okay. So now what is P of y1? P of y1, which is nothing but, P of y1 is nothing but 0.48 plus 0.12, which is equal to 0.6. Now P of y2, what is P of y2? P of y2 equal to 0.12 plus 0.28, which is equal to 0.4, right? Now this is P of y1, P of y2. Then I want h of y. What is h of y? H of y, entropy of a source y, which is equal to, directly write, minus now 0.6 log 0.6 base 2 plus 0.4 log 0.4 base 2. Now which is equal to, now this is 0.6, 0.9709. This is entropy of a source y. Okay. So for finding mutual information, h of y is required. H of y is completed. Now I want h of y by x. What is h of y by x? Now see, this is the formula for h of y by x. See here, to find h of y by x, we required joint probability p of x comma y, and we required a conditional probability of p of y by x. Is available or not? Now you calculate. Now what is h of y by x? Now this is h of, directly I write, h of y by x, h of y by x, which is nothing but minus. Now this is all or minus, because log 1 by, actually we are taking 1 by means this is minus. So p of x comma y, what is p of x comma y? This is, this rows and columns are respective values are multiplied. 0.48 p of x comma y, 0.48 multiplied with log of p of y1 by x1, which is equal to 0.8, which means p of x1 y1 log p of y1 by x1. What is p of x1 y1? 0.48. P of y1 by x1 is 0.8. That's it, like this. Okay. 0.48 into 0.8 plus 0.12 into 0.2 plus 0.12 into 0.3 plus 0.28 into 0.7. Now this is the h of y by x. Now this is nothing but 0.7855 bits per symbol. Okay. Now this is h of y by x. This is h of y. Now what is the mutual information? The mutual information, which is nothing but the mutual information I of x comma y, which is equal to I of x comma y, which is equal to h of y minus h of y by x. H of y is already calculated, 0.9709 minus h of y by x, 0.7855, which is equal to, now this is 0.1853 bits per symbol is the mutual information. Okay, no. Okay, now the same similar question. Okay, you just concentrate once again. Now he is giving the channel diagram. Okay, now what he is giving is, consider the conditional probability as shown in the figure below. Consider the conditional probability as shown in the figure below. These are the conditional probability as shown in the figure below, channel diagram, and he said that x1 and x2 are transmitted with equiprobable. In this question is mentioned. Now consider the channel diagram as shown in the figure below. This is the channel diagram, and he says that x1 and x2 are transmitted with equiprobable. There are two symbols. What is the equiprobable occurrence of each symbol? 1 by 2. 1 by 2. Two symbols. 0.5, which is equal to 0.5. So what is P of x? First we will write that this is the channel diagram. Therefore y1 by x1, 0.5. Now y2 by x1, 0.5. Now y1 by x2, 0.25. y2 by x2, 0.75. I am already saying that when row addition is possible, then that is P of y by x. So this is P of y by x, and now he is asking same mutual information he is asking. So now we want to find first joint probability, which is equal to P of x into P of y by x. What is P of x here? P of x now P of x1 and x2 are equiprobable. So 0.5 into 0.5, 0.5 into 0.5. Now 0.5 into 0.25. Next 0.5 into 0.75. Now this is nothing but 0.25, 0.25, 0.25, 0.375. Now this is 0.125. Okay. Now this is the joint probability. Now once the joint probability is completed, then we want to find P of y1, P of y2, because row addition, column addition is possible only in joint probability. Now this is P of y1, P of y2. What is P of y1? 0.25. 0.25 plus 0.125. Now P of y2, 0.25 plus 0.375. Now which is nothing but, this is P of y1, 0.375, 0.625. Okay. Now what is h of y? H of y, which is nothing but entropy of a source y, which is nothing but here P of y1 is available. 0.375 log 0.375 base 2 plus 0.625 log 0.625 base 2. And this is entropy of a source y, h of y, which is 0.954. And a mutual information. For finding mutual information, now we required h of y by x. What is h of y by x? H of y by x means we want joint probability is already calculated and conditional probability is available, P of y by x. Then you straight over use this one. Now which is nothing but 0.25 into log 0.5 base 2 plus 0.25 into log 0.5 base 2 plus 0.125 log 0.25 base 2 plus 0.375 log 0.75 base 2. Now this is conditional entropy of h of y by x, which is equal to, this is 0.954. Then what is the mutual information? H of y minus h of y by x. Now h of y, which is 0.954 and this is 0.905. So minus 0.905, which is equal to 0.05 bits per symbol is the mutual information. Now number of bits transmitted through channel per symbol is the mutual information. Okay. Now this is the way how to calculate the mutual information. Okay. Now if sometimes he is giving P of x by y, then you better go to h of x by y calculation and use this form. Okay. According to that your situation. Okay. Now you see here same mutual information I am calculating, but if you see here in this channel diagram, now sorry, one more point actually I missed. This is source x1, this is source y2, transmitter, receiver. This is a direct channel. Okay, this is called as direct channel, and this is called as crossover channel because this is crossing some other channel. No? This is called as crossover channel. And similarly, this is a transmitter, this is receiver, this is direct channel, and this is crossover channel. Okay, these two are called as crossover channels, and this is called as direct channels. Okay, x1, y1, x2, y2. Now when x1 is transmitted, y1 is received with a probability of 1 minus p. x2 is transmitted, y2 is received with a probability of 1 minus p. When x1 is transmitted, y2 is received with a probability of p. When x2 is transmitted, y1 is received with a probability of p. Okay. When x1 is transmitted, y1 is received. When x2 is transmitted, y2 is received. Now these are the probabilities, right? Now see here. Now these are the channel diagram and with the probabilities. But if you observe, now this first channel probability and second channel probability is same or not? So if error probability is same for both the channels, now that particular channel is called as binary symmetric channel. If error probability is same, means here 0.5, 0.5, 0.3, 0.3, 0.5, 0.5, 0.6, 0.6. If error probability is same for both the channels, now that particular channel is called as binary symmetric channel. Which channel? Binary symmetric channel. If error probability is same for both the channels, now that particular channel is called as, that particular channel diagram is called as binary symmetric channel. So error probability is same for both the channels. Now that particular channel is called as binary symmetric channel. Now see here. Now when x1 is transmitted, y1 is received with a probability of 1 minus p. When x1 is transmitted, y2 is received with a probability of p. When x2 is transmitted, y1 is received with a probability of p. x2 is transmitted, y2 is received with a probability of 1 minus p. And in a easy manner, in a conditional probability, diagonal and opposite diagonal probabilities are same, then that particular channel is called as binary symmetric channel. Okay, so this is the binary symmetric channel. Now he is asking to find the mutual information. Now let us see. Now this is a probability of a source x1 with probability alpha, and probability of x2 source, probability of source x2 with a probability of 1 minus alpha, let us assume, because some of the probability is always known. So now this is the conditional probability, and this is P of x1 and P of x2. Then this is the channel diagram. Okay, this is the channel diagram. Now a joint probability. The joint probability P of x comma y, which is equal to P of x into P of y by x. Now see here. Now P of x1 alpha into 1 minus p, P of x1 alpha into p, P of x2 1 minus alpha into p, P of x2 1 minus alpha into 1 minus p. Right? Now this is a joint probability. Now see here. Now h of y by x, now what is h of y by x? H of y by x formula is here. Now this is h of y by x. Now the joint probability multiplied with conditional probability. Now what is the joint probability? Alpha into 1 minus p log 1 minus p base 2 plus alpha p log p base 2 plus 1 minus alpha into p log p base 2 plus 1 minus alpha into 1 minus p log 1 minus p base 2. Now this is h of y by x. Now what is h of y by x? Now this is h of y by x, which is equal to, now this minus alpha p, this plus alpha minus alpha p. Now see here. Now minus this one is cancelled. Now this alpha p is cancelled. Now here alpha log, this is h of y by x is P log P base 2 plus 1 minus P log 1 minus P base 2. Now this is the answer. Why? Because this is alpha P, this is minus alpha P, cancel, therefore 1 P log P is available here, and this is minus alpha into this something, now this is plus alpha into something, this is cancelled, therefore 1 minus P into log 1 minus P base 2. Okay, so now this is nothing but h of y by x. Now what is the mutual information? Now the mutual information I of x comma y, which is equal to the mutual information I of x comma y, which is equal to h of y minus h of y by x. H of y minus h of y by x. Now what is h of y? Now this is h of y. There is a minus sign here, right? So now this minus minus cancel, therefore P log P base 2 plus 1 minus P log 1 minus P base 2. Now this is the mutual information, right? Now this is the mutual information of a binary symmetric channel. Now I want the maximum mutual information. The maximum mutual information is nothing but the channel capacity. The maximum mutual information is nothing but channel capacity. What is the maximum? Here h of y maximum, but this probability is not in our control. Probability of error depends upon the noise. 1 minus P log 1 minus P base 2. So this is the channel capacity. Maximum information, maximum mutual information is called as channel capacity. Now which is nothing but C, which is what is h of I maximum. So maximum entropy of a discrete source. The maximum entropy of a source where source generating two symbols. Now what is h of y maximum? Now h of y maximum, which is nothing but, you know, the maximum entropy formula, log m base 2, where m is how many symbols here? Two symbols. So m is 2. Now P log P base 2 plus 1 minus P log 1 minus P base 2. So finally the maximum mutual information is nothing but channel capacity. Log 2 base 2 is 1 plus P log P base 2 plus 1 minus P log 1 minus P base 2. This is the binary symmetric channel capacity. This is the binary symmetric channel capacity. Note down this. Now see here. Now this is a binary symmetric channel. Now the question is like this. In a binary symmetric channel, error probability is 0.1. In a binary symmetric channel, error probability is 0.1. Then he is asking the channel capacity. Now what is the channel capacity? This is 1 plus error probability is 0.1 log 0.1 base 2, 0.9 log 0.9 base 2. And this is the channel capacity, which is 0.531 bits per symbol. So, and you can also observe that the channel capacity is depends upon the error probability. The channel capacity depends upon the probability of error. Yes, when error probability is more, unnecessary bits or redundant bits are also transmitted, then the capacity decreases. Okay. Now this is the channel capacity of a binary symmetric channel. Now similar to them, there is another channel. Now that also we'll see here. Now we are transmitting x1 and x2. So when we are transmitting x1 and x2, how many symbols we want to expect at the receiver side? Two symbols, y1 and y2. But here, when I am transmitting two symbols, but at the receiver side, third symbol is also occur. At the receiver side, third symbol is also occur. Now that is nothing but an error or not? When I am transmitting two symbols, I am expecting at the receiver side is two symbols, but at the receiver side, third symbol is also occur. Now that third symbol, that extra symbol should be erased or not? Yes, that extra symbol should be erased. Now that particular channel is called as binary erased channel. Okay, that particular channel is called as binary erased channel. Now we will try to construct if that situation is coming, what happen? Okay, so when x1 is transmitted, y1 is received with a probability of 1 minus p. When x1 is transmitted, y2 is received with a probability of p. When x2 is transmitted, y2 is received with a probability of p. When x2 is transmitted, y3 is received with a probability of 1 minus p. Now this is the channel diagram. Now let us assume, now this is p of x1 is alpha, p of x2 is 1 minus alpha. Now what is the conditional probability? Now see here, the conditional probability here is p of y by x but here transmitting is only two symbols, x1 and x2, but the receiving is three symbols, y1, y2, y3. So when x1 is transmitted, y1 is received, y3 is received. Now see here, when x1 is transmitted, y1 is received with a probability of 1 minus p. When x1 is transmitted, y2 is received with a probability of p. When x1 is transmitted, y3 is received, there is no probability of that symbol, 0. When x2 is transmitted, y1 is received, 0. When x2 is transmitted, y2 is received with a probability of p. x2 is transmitted, y3 is received with a probability of 1 minus p. This is the conditional probability of a binary erased channel. Okay. So now this is a binary erased channel. Now this is the joint probability. What is the joint probability? Alpha into 1 minus p, alpha into p. Now this is another case is also coming here. Now alpha into 0, this is 0. Now 1 minus alpha into 0, this is 0. 1 minus alpha into p. 1 minus alpha into 1 minus p. 1 minus alpha into 1 minus p. Now this is the joint probability. Okay. Now once the joint probability is available, conditional probability is available, so we can find the mutual information. Same procedure. Then if I use the mutual information, Same procedure if you follow. Now you are getting a mutual information as I of x comma y, which is equal to 1 minus p into alpha log 1 by alpha base 2 plus 1 minus alpha log 1 by 1 minus alpha base 2. This is the mutual information of a binary arrays channel if you do the same procedure. Okay. So, if you observed or not here, now what is alpha log 1 by alpha? See here, alpha log 1 by alpha plus 1 minus alpha log 1 by 1 minus alpha base 2. This is nothing but, what is this? This is nothing but entropy of a source x or not, h of x. Is it or not? Because this is p of x1 and p of x2. Therefore, this is entropy of source x. So, can I write now? This is the mutual information h of I of x comma y, which is equal to 1 minus p into, now this is h of x. This is the mutual information. So, this is the mutual information. Then the maximum mutual information is called as channel capacity. I of x comma y maximum, the maximum mutual information, which is nothing but 1 minus p into h of x maximum. The maximum mutual information 1 minus p into h of x maximum. Therefore, which is equal to, what is the maximum value of h of x? The maximum entropy. What is the maximum entropy of a binary source? Now the binary source h1 two symbols, so the maximum entropy, which is nothing but 1. So therefore, the maximum mutual information, which is nothing but channel capacity, which is equal to 1 minus p. This is 1. This is the maximum mutual information is called as channel capacity, and this is the mutual information. This is the mutual information. Then what is efficiency? What is the utilization factor? The utilization factor or efficiency is I of x comma y by channel capacity. Now, which is nothing but, what is I of x comma y? I of x comma y is 1 minus p into h of x by channel capacity is only 1 minus p is cancelled. So, utilization factor is nothing but entropy of a source x, and redundancy which is equal to 1 minus utilization factor. So, very simple formulas or not. So, now let us solve one problem. In a binary arrays channel, now we'll see question. Here is the question. In a binary arrays channel, error probability of error is 0.1 and alpha is 0.6. Then find mutual information, capacity, and all these things. Then we'll start here. Now, first of all, whenever alpha is given, now first you find h of x. What is h of x? H of x is this. H of x is nothing but, what is h of x? Alpha log 1 by alpha. Now see here, this is alpha, which is nothing but 0.6 log 1 by 0.6 base 2 plus 1 minus 0.6 means 0.4 log 1 by 0.4 base 2. Therefore, this is h of x, which is nothing but this is 0.97. So now what is the mutual information? The mutual information, which is nothing but 1 minus 0.1 means 0.9 into, now this is 0.97. Now this is nothing but mutual information, which is 0.8738. Now this is the mutual information. Now the channel capacity is nothing but very simple, 1 minus probability, 1 minus 0.1, 1 minus 0.1, which is nothing but 0.9. This is 0.9. Now efficiency or utilization factor, which is nothing but h of x. What is h of x? 0.97, and redundancy is nothing but 1 minus 0.97, now which is nothing but 0.03, which is nothing but 3% is redundancy, and efficiency is 97. So we are using 97% of channel capacity, and we are not utilizing the channel capacity is only 3%. Okay. Now this is the binary erased channel. Okay. Now this is the binary erased channel, and in binary erased channel, channel capacity, mutual information, and all these things. Okay. Now the question is why this extra symbol is generally coming. Now if you want to transmit two symbols, now why this extra symbol is coming? Now see here, this is the reason behind that. This is the threshold comparator. This is threshold comparator, right? Now this is the threshold comparator. Now see here. Now this is noise affected binary data. This is binary data plus noise. Now this is the threshold voltage. Threshold voltage. Am I right or not? Now you know that. Now this signal strength. This is the noise affected binary data signal strength. Right? Now if that signal strength is greater than threshold volt, this signal strength is greater than. Now signal strength is greater than threshold voltage, it will be treated as binary 1. If signal strength is less than this threshold voltage, then it will be treated as binary 0. If this signal strength is equal to threshold voltage, then this extra symbol will occur. This extra symbol will occur. This extra symbol will occur. Okay. Now this is the way that generally this extra symbol may chance to occur. So whenever this extra symbol is occur, now how to erase that one? That is erased by using ARQ request. ARQ request. Automatic request for retransmission. This is automatic request for retransmission. Means then this is a transmitter. Now the whenever then this is transmitter, this is receiver. The receiver is asking that, now receiver is sending, the receiver is sending ARQ request. The receiver is sending ARQ request means automatic request for retransmission. Whatever the information you are transmitted just now, again you retransmit. So again what the transmitter is doing, transmitter is again transmitting the same symbol. Whenever the transmitter is transmitting the same symbol, definitely this problem is arises, because now at that time the noise may be varies. Now effect of noise may be changes. Therefore it may greater than or it may less than. It may binary 1 or binary 0. That extra symbol it won't get. Okay. Now this is automatic request for retransmission.